Today we will see very important and interesting problem, okay, that will be very useful for exam point of view. So the problem is find the Fourier cosine and sine transform of x to the power n minus 1, okay. Now how to solve? So here the function f of x is what? X to the power n minus 1, where n greater than 0. Now we have to find what? Fourier cosine and Fourier sine transform of f of x, okay. So Fourier cosine transform of this means Fourier cosine transform of x to the power n minus 1. So what is the formula? That is square root of 2 by pi integration from 0 to infinity x to the power n minus 1 cos wx dx, okay. Now what is Fourier sine then? For Fourier sine, x to the power n minus 1 is square root of 2 by pi integration from 0 to infinity x to the power n minus 1 sine wx dx, okay. So we have to find these two integral, but there is some problem, okay. What problem? Here if you see, there is x to the power n minus 1 term is there, another is cos wx. So we don't need the n value, and if we integrate, so we have to integrate and integrate, means we have to keep on integrating, because x to the power n minus 1 is there, we have to reduce till it will be linear form and constant form, means x. So it will be very difficult to handle. So in such cases, what to do? There will be a trick to do, okay. We have to apply the de Moivre's theorem. We have to apply the complex form. So what to do? We'll see. If I take fc plus ifs, okay, then what will happen? Fc will be square root of 2 by pi, okay, integration from 0 to infinity x to the power n minus 1 cos wx dx, okay, plus I into what? Square root of 2 by pi integration from 0 to infinity x to the power n minus 1 sine wx dx. So this is the form. Now what will happen? So if we write it in compact form, it will be square root of 2 by pi integration, okay, 0 to infinity x to the power n minus 1 into what? Cos wx plus I sin wx dx, okay. But what is cos wx plus I sin wx? We know that e to the power I theta is what? Cos theta plus I sin theta. So if we apply this formula here, then what will happen? It will be square root of 2 by pi integration 0 to infinity x to the power n minus 1 e to the power what? Iwx dx, okay. Now it is simple, okay. Here also we have to integrate, okay. But what to do? If we directly integrate, again it will come, because e to the e exponential function is there, x is there. So we'll apply here gamma function, okay. We'll see gradually what is gamma function, okay. So what to do? We have to take some substitution here. So take minus t equal to Iwx. So why I took minus t, that also will reveal, we'll see, okay. So if that case, then minus dt equal to Iw dx, or simply dx equal to what? Minus dt by Iw. And what is x? X will be minus t by Iw. So we have to substitute all this here, but the limit will be same, limit will not change if we apply, okay. So what will happen? The factor will be 2 by pi, square root of 2 by pi 0 to infinity. Now x to the power n minus 1 is there. So x is minus t by iw to the power then minus 1 e to the power minus t. Okay. Then dx is what? Minus dt by iw. Okay. So this again we can write square root of 2 by pi. Okay. Now here we have constant term, so that those things we will take outside. So here minus 1 by iw, here also minus 1 by iw. So I can write minus 1 by iw to the power n. Okay. Then integration here 0 to infinity. Now this I can write first. So e to the power minus t into t to the power n minus 1 dt. So this is what we called gamma of n. Okay. So this is our gamma function. So we define like this. So gamma of n. Now what will happen? So finally we will get square root of 2 by pi. Okay. Minus 1 by I omega to the power n, then gamma of n. Now from here what we will get? Square root of 2 by pi into minus 1. If we write in this form, so what will happen? It will be cos pi by 2 plus I sin pi by 2. Okay. How it will came? I will tell you. Okay. Then we will do that. So minus 1. Now here I will do this thing. So minus 1 is what? I into I. Okay. Now below there is a I. So if I into I by IW, I will write. So I will cancel. So finally I by W. But what is I? I equal to cos pi by 2 plus I sin pi by 2. So that formula we have applied. So to the power n gamma n. Now again what we know, okay, de Moivre's theorem. So from de Moivre's theorem what we know, if we have cos theta plus I sin theta to the power n, that we can write cos n theta plus I sin n theta. So if we apply this one here, so what will happen? Square root of 2 by pi cos n pi by 2 plus I sin n pi by 2 divided by w to the power n into gamma n. So this we will get. Now what we have to do? The question is we have to find Fourier cosine and Fourier sine transform. So from this we have to find the Fourier cosine and Fourier sine. How to do? The real part will give Fourier cosine transform, whereas the Fourier sine transform will be the complex part. So that we have to separate and find out the answer. Hence the answer is Fourier cosine of x to the power n minus 1 will be real part of this. So square root of 2 by pi gamma n into cos n pi by 2 divided by w to the power n. Okay. Similarly, Fourier sine of x to the power n minus 1 will be what? Real part. So real part is associated with I. So what will happen? It will be square root of 2 by pi gamma n by w to the power n into sine n pi by 2. So this way we can find such type of problem. So we have to always read the problem carefully. Okay, accordingly we have to apply the formula, or we have to use this trick, that is FC plus IFS.